Now let's talk about the trapezoid. Trapezoid is a quadrilateral, a four-sided object with two parallel sides. This is like what the lions stand on in the circus, called a trapezoid. So the parallel sides are called the bases, and so I would mark those as parallel. That's my little parallel marking. So the two sides that are parallel are called bases. The two sides that are not parallel to each other are called legs. And the angles to the bases are also called base angles. All right, so here's one type of trapezoid. Let's call this A, B, C, D. And BC is parallel to AD. That would be a trapezoid. Here are my bases, here are my legs. AD, I don't want to put it together. Angle A and angle D are base angles because they're on line segment AD. Angle B and angle C are also base angles because they are on this upper base here. Now, whenever the midpoints of the two legs are intercepted, let's see, we'll call this M, that's the midpoint of AB, and we'll call this N, that's the midpoint of CD. That segment is called the median. Remember, right down the middle. And that median is also parallel. That median is parallel, equidistant from both of the bases. And we'll have a calculation at the end of this section on how to find the length of MN. Not surprising, if it's at the midpoint, you're not going to be surprised to find out that it's 1/2. But you might be surprised to find out it's 1/2 of what? All right, so if the two, here we have a trapezoid, because here I have parallel lines. If the two legs are congruent, that will make it an isosceles trapezoid. Remember, an isosceles triangle has two sides that are congruent. An isosceles trapezoid will have two legs that are congruent. So RS and VT are parallel, but the length of RV and the length of ST are equal. And so imagine here we have our parallel lines, parallel line cut by a transversal. What do we know about these two angles? Same side interior angles are supplementary. So in a trapezoid, your consecutive angles formed by the transversal or by the leg, consecutive interior angles are supplementary because they're formed by parallel lines that are cut by a transversal. So in this figure, they actually assumed these two lines and they had their transversal here. So these two angles would be supplementary. So angles that are on the same leg are supplementary. That's how you might think of it. So we have seen just a trapezoid, and then we've seen an isosceles trapezoid. But what if one of the sides is perpendicular to the base? That's called a right trapezoid. Just like a triangle with a 90-degree angle is called a right triangle, a trapezoid with a 90-degree angle is called a right triangle. And you know what? If this is 90 degrees, same side interior angles are supplementary, and these are parallel. That's also going to be a 90-degree angle. All right, so let's see if we can find all of the angle measurements for this trapezoid, knowing what we know about quadrilaterals and parallel lines. So this is a four-sided object. So the sum of all of the angles is going to be 360. So how did I get that? 4 minus 2 times 180. Or you can just think of a square as a quadrilateral, and so you know that's 360 degrees. But just in case, number of sides minus 2 times 180, that's the sum of all the angles. So the sum is going to be 2 times 180. So we know that the sum of all the angles is 360. All right, so let's say H is 107 and K is 58. So we have 107 and 58. We know that these two angles are supplementary. So the measure of angle H plus the measure of angle J has got to equal 180. And we know the measure of angle H is 107. Plus the measure of angle J is 180. So let's subtract 107 degrees from both sides. And we get the measure of angle J is going to be 73 degrees. There's a 73-degree angle. So now if we want to find the measure of angle L, we could add up 107, 73, 58, and subtract from 360, because we know the sum of all four angles is 360 degrees. Or we can just say we know angle L and angle K here are supplementary. The measure of angle L plus the measure of angle K have to equal 180. So the measure of angle L plus 58 is going to equal 180. So let's subtract 58 from both sides of the equal sign, and we have the measure of angle L is going to be 122 degrees. So let's check 107, 122, 58, and 73. If we are right, they should add up to 360. So do that by hand or do that on your calculator, and you will find out that they add up to 360. So that's kind of our check that we have not made a calculation error. All right, as far as altitudes, now we've seen altitudes of triangles from a vertex perpendicular to the opposite side, and we've seen altitudes of parallelograms from a side perpendicular to the opposite side. The altitude of the trapezoid is always going to be from base to base. It's the length from base to the other base. Okay, you're not ever going to see the measure of the leg to the leg. You want to see the height of the trapezoid. It can be from a vertex, making a 90-degree angle. It can be in the middle of the segment of one of the bases. I can take from K and go up, make it perpendicular, it'd be outside the trapezoid, but the length of the altitude is always taken from base to base. So here are some theorems we can use. The base angles of an isosceles trapezoid are congruent, and the diagonals of an isosceles trapezoid are congruent. So in an isosceles trapezoid, not only are the bases parallel, but the legs are congruent also. I was looking, here we go. Here's my isosceles trapezoid right here. So that side is congruent with that side. So that means this angle is congruent with that angle, or that angle is congruent with that angle. And also, the length of this diagonal is the same as the length of that diagonal. Only for isosceles trapezoids. Now remember we drew the median The median is the segment that connects the midpoints of the legs. The length of the median is 1/2 or the average of the sum of the two bases. So if this is my trapezoid, and this is 4 and this is 10. If that's my midpoint and that's my midpoint, that's going to be my median. The median is the average, or 1/2, the average of the sum of the two bases. 1/2 of 14. So in this case, the median would be 7. That kind of makes sense even as you see it there. And this is also going to be parallel with the bases of the trapezoid. So if you have an isosceles trapezoid, then the base angles are congruent. Well, if you have a trapezoid where the base angles are congruent, then it must be an isosceles trapezoid. If the diagonals are congruent, then it must be an isosceles trapezoid. And this last one. So if 3 or more parallel lines intercept a line segment, and so here's a parallel line, and here's here's a set of parallel lines, and here's a set of parallel. So let's say there are 3 or more parallel lines, and I know when I cut this transversal, if I know that that segment and that segment are congruent, that means that any diagonal I cut, that segment will be congruent with that segment. So that's what this theorem is saying. If 3 or more parallel lines intercept congruent line segments on a transversal, then they're going to be congruent line segments on any transversal you might draw.